Hey everybody, we are going to spend some time together talking about metals, nonmetals, and metalloids, specifically looking at their physical properties and what properties make each group the group they are. Make sense? Stay with me, I'll make it make sense. Alright, so make sure that your presentation is open so that you can type in the notes that you get from what I'm presenting, and also as I'm going through the presentation, you are welcome to stop and hit pause at any time that you need some extra few seconds or extra few minutes to type in the answers to the questions that you will find on some of the slides. So let's go ahead and get started. So our first page shows us our essential questions. These are those questions that you should be able to answer when we finish our lesson. And those questions are, what are metals, nonmetals, and metalloids? And question number 2, how are physical properties used to compare metals, nonmetals, and metalloids? But before you try to answer those, or before we go through the lesson to answer those, I want you to try to see do you know any of these answers yet? So over on the left, you're going to reflect on those. Question number 1 says, if you were actually quizzed today, would you be able to answer either one of these questions? One of these essential questions on the right. And if you think you could, tell me in the answer box where it says type your answer here. And then question number 2 says, which questions would you need to learn more about to answer confidently? And just be honest. If you don't know either one of the answers, that's fine. Just put on number 2, question numbers 1 and 2. And that number 1, you're like, neither. I don't think I could answer either one. Just be honest, hit pause, write your answers, and come back to me when you're done. All right, ladies and gentlemen, we're going to go on to the next slide now that you've answered those 2 questions. Okay. So here you're going to start filling in your notes. These physical properties in general are things that can be observed or measured, and those are some of the words that you need to fill in on your paper or on your slide. And they don't change the composition of matter. That means that they're not going to make a new substance, much like a chemical change would. Physical properties are used to observe and describe matter. Using your 5 senses. What do you see? What do you smell? What do you hear? What do you feel? What do you taste? But remember, we don't taste anything in a lab. Now, physical properties, specifically some categories of physical properties would be the appearance, texture, color, odor, density, luster, conductivity, malleability, and ductility. And I'm sure all of those words look very familiar to you from the vocabulary words we've already started studying for this unit. So we're going to look at what does an object look like? What is its texture? What is its color and odor? And any of these other physical properties that are listed here. And based on what we decide their physical property is in any category, that's going to help us decide if it's a metal, a nonmetal, or a metalloid. All right, so while you're looking at these physical properties, appearance, texture, color, odor, density, luster, conductivity, malleability, and ductility, come over to the right and see if you can name some physical properties of the ice. Type your answer here. You can hit pause and then come back to me when you're done. All right, I'm sure that you probably put something like slippery or wet or a cube, clear, shiny luster maybe, not a good conductor. Maybe you put insulator down. It's not malleable because it cannot be hammered into thin sheets, and it's not ductile because ice cannot be pulled into thin wires. So let's real quickly go over those vocabulary words that we have been studying already with some of our vocabulary activities. We talked about luster. This is how a metal surface reflects light, and we typically say shiny or dull, but you can also say that an object has luster, meaning it's got shine to it, or an object does not have any luster, which means it would be dull. Okay. And ductile refers to the way most metals can be stretched into wires. And here's a great example already. I don't know if you know an example for a metal that can be easily made into a wire, but this is a picture of raw copper, and then you can see where it's now being pulled into a wire. So you could very easily stick the word copper in your answer box right there. Our next word is malleable, and it refers to the way most metals can be hammered or rolled into thin sheets. Much like this metal has been warmed and now is being reshaped into a horseshoe, and this aluminum foil was hammered or rolled into this thin sheet. So if something is malleable, those metals that are malleable, basically you can say they're being reshaped. But it's usually through a hammering or a rolling into thin sheets. Brittle is pretty much the opposite. If something is not malleable, it's typically brittle. Oops, sorry about that little beep if that showed up. The opposite of malleable is brittle, in that brittle makes things shatter into pieces. Or if something is brittle, it shatters into several pieces. Another way to say that is that it will fracture or fail with a small amount of force, much like the pictures you can see with the glass and the silicone and even chalk. All right. Our next word is conductivity. You guys really know this one probably even from 4th or 5th grade. This is any substance that allows electricity or heat to pass through it very easily. And if you can think of any other metals or materials that are a good conductor, type that in the box below. I am sure that you guys probably put some great answers of other metals that are good conductors. Some people may have even put human body, because we can allow electricity to go through us. So those would be some great examples. Another vocabulary word is insulator, which is the opposite of, it's the opposite of a conductor, in that it keeps energy from easily transferring through it. So it doesn't allow electricity and heat to pass through it like a conductor would. Our metals, as you can see, and we've already color-coded one periodic table, and we know that most of the elements on the periodic table are metals, and that those 88 elements that are on the left of that staircase, your staircase is right over here where the metalloids are, that everything to the left of it are metals, or they're very metal-like elements, and most are solid at room temperature. Okay, so these are the specific physical properties of metals. They have luster, which is shininess. They're good conductors of heat and electricity. High density, meaning when they say heavy for their size, it could be a very small, like a magnet or something like that, but it has a lot of weight to it. It has a lot of mass to it, so the density feels heavy. High melting point, meaning it would take a really high temperature to melt it. Ductile, most metals can be pulled or drawn out into thin wires, and they can also, most metals can be hammered into thin sheets, which would make most metals malleable. So on this next slide, we're talking about metal uses, and you can see the examples here. Copper is good for wiring and coins. Gold can be very easily manipulated into jewelry or even dental fillings. Lithium is an element that is used both in medicines but also in batteries. You might notice the little round flat batteries, those are lithium batteries. And if you can think of any other, what are some other uses of metal? Type your answers in that box. I'm sure that many of you probably put down some examples of for building structures, metals and phones, building fences, things like that. Metals can be used for quite a bit of things since there's so many of them for us to use. Okay, on this page we're going to identify which set of colored elements represents metals. So whichever one you think are wrong, you would bring them over here, and whichever one you think is correct, you're going to leave it over in this space, and you're going to drag it out. To take up the whole space. Give you just a minute to do that. You hit pause and come back to me. Okay, so the correct answer would be this picture is not metals. That is our nonmetals, and this picture is for the metalloids, which leaves this one with the whole bunch of them colored in. That would be our picture for metals. Okay. Turn that back. Whoops. Okay. So I want you to take just a few minutes. You can hit pause in a moment. I want you to identify which of these elements over here are metals. And so you have to look at where they are on the periodic table. And so you can just list your answer here, which of these, and you can just put the symbols in there, which of these are metals, and then below that, list some of the physical properties that they're going to have to share if they are considered metals. Go ahead and hit pause and come back to me. Okay, so we're gonna talk about that one in class as a quick review. We're going to go ahead and talk about nonmetals now. We know that nonmetals are to the right of the stair step. They are the opposite of metals. Their properties are the complete opposite, and most of them are gas at room temperature. The physical properties of nonmetals, again, are the opposite of metals. So there's no luster, they're dull, they're poor conductors, they're brittle, they can break easily, they're not ductile or malleable, they have a low density and low melting point. So look at some of the uses for oxygen and see if you can list some other uses in the text box. Okay, I am going to use this as a discussion question in class since I'm running out of recording time, so I'm going to go through the rest of this. Take some time to drag over the correct picture that represents nonmetals. I'll give you just a minute. I'll make that a review question as well in our class discussion. And go ahead on this page and identify which of these elements are nonmetals. Type your answer in this box, and you can certainly extend it if you need more room. And underneath your list of these elements that are nonmetals, type out some of the physical properties that nonmetals share. All right, so now that you've done that, I'm going to use the think about it question as another review question, so make sure you're ready to answer that when we come together as a class. The last section we're going to talk about are the metalloids, and they are found on the staircase. There are, you call it the zigzag line, and these metalloids are elements that typically have properties of both metals and nonmetals. And it's a good thing to remember right here, boron is on the top, and a funny way to remember where the metalloid staircase starts is boron, the moron at the top of the stupid stairs. So here's boron at the top, and that's the staircase. Okay, so physical properties of metalloids, they're solids typically. They can be shiny or dull. They are typically ductile or malleable, but when it comes to conductivity, they conduct electricity better than nonmetals, but they do not conduct electricity or heat as well as metals. So they're kind of in the middle there. All right, so on this next page, you're looking at the uses of metalloids. See if you can come up with some other ideas and type your answer in this text box. On the next page, on this one, you're going to show which diagram shows the metalloids. Drag the other ones over here, and the correct one, resize it. Okay, and on this page, again, I want you to identify which of these elements are metalloids and type your answer in your text box. And then also underneath that, list what physical properties do these elements share. Okay. And then lastly, you're going to come to some review slides. You have a last look. This is a drag and drop where you're going to be dragging the properties of metals here, the nonmetals here, and the properties of metalloids over here. And then some common uses right here. So certainly can look back at your notes if you need to. And then your last two slides, stop and answer these check for understanding questions. And that's what we'll review when we come back together as a group. All right, hope you enjoyed this form of note-taking. I think we're going to try it some more. I look forward to our class discussion. Thanks for staying with me and filling out your notes. Bye.